Okay, so we're going to take up quiz 2.1. So the first few questions were true or false. In the first one, I can use SOHCAHTOA for any triangle. It's only for right angle triangles. So that's false. Not any triangle, only right angles. And that means that the second one's true. So yeah, for all right angle triangle problems, we can do it. And the last question says the cosine ratio can be more than 1. Well, that seems like it's true, but if we draw a triangle and figure out there's hypotenuse and adjacent, and cos theta is adjacent over hypotenuse because SOHCAHTOA, and which side is bigger, adjacent or hypotenuse? So we should answer that a hypotenuse is always bigger. And if the hypotenuse is bigger, that means that the denominator is bigger. And a number where the denominator is bigger means that it's less than 1. So that's false. Okay? In this next one, find the value of x and y. A lot of people said you can't do it because you can't use SOHCAHTOA on non-right angle triangles. And it's true, you can't use SOHCAHTOA, but we should be able to see that there are two triangles which are similar here, ADE and ABC. They're similar because the parallel lines right here tell us that they are, right? So we can say that we can set up some corresponding side ratios, and we can say that 5 over y, AD over AB, is equal to 7 over 8.4, and that's equal to x over 8. And now we can say I'm just going to use that first part to try to solve for x. So we have to solve the ratio, 7 over 8.4 is equal to x over 8, and to do that we can multiply by 8 on both sides. And we end up with x is roughly 6.7. And then we can say, well, we still need y, so let's look at that other ratio. And we have the variable on the bottom, and we don't like that. We want the variable on top, so we can flip everything. So take the reciprocal of both sides, and now we can multiply both sides by 5 and end up with the fact that y equals 6. This one is just to solve the triangle. Remember, to solve the triangle means find all the missing sides, all the missing ratios. So first, let's find this and let's call it x. As it's a right angle triangle, so we can use Pythagorean theorem. So 4.1 squared plus x squared is 12.2 squared. And then x squared is 132.03. I'll let you check that, but just make sure you do all the arithmetic properly. I'm sure you'll be able to do that. And then that makes x 11.5. So next, let's just pick one of the angles to solve for. I'm going to pick that one right there, A. And we remember that we can use SOHCAHTOA, and 4.1 is opposite of A. And 12.2 is the hypotenuse. So that means that we can say sine A is 4.1 over 12.2. Well, 4.1 over 12.2 happens to be 0.3361. So, and now, remember we said whenever we're finding an angle, we have to use the inverse trig ratio. So A is sine inverse 0.3361, which makes it 20 degrees. So I can add into my diagram 20 degrees there. And now for the last angle up there, B, we can just use the fact that all triangles have to add up to 180. So B has to be 70. Okay. Here we just have to solve for x. So first, we can name the sides adjacent and hypotenuse. Next, we can say, well, we know SOHCAHTOA. So adjacent hypotenuse means cos 32 is equal to x over 9, or adjacent over hypotenuse. Now we can say cos 32 is 0.8480 is equal to x over 9, and we can multiply both sides by 9 to end up with x is 7.63. Okay, so this one was just a simple question and trying to know which part of SOHCAHTOA we're trying to use. Okay. Next question says, a student 1.6 meters tall is looking at a house, and he's 12 meters from the house. And we also know that he looks up at an angle of 32 degrees. So that angle is from the horizontal, right? So 32 degrees. And now we want to try to find the height of the house. Well, the opposite part is right there, And we know that that 12 can be moved up to the horizontal. So now I can use tan because I've got opposite adjacent ratio. And tan 32 is opposite over adjacent, so opposite over 12. So 0.6249 is equal to opposite over 12. Multiply both sides by 12, and we get opposite is equal to 7.5. Now the 7.5 is just this height right here. We're still missing the person's height. And to get the person's height, all we have to do is add 1.6, because we're told at the beginning that he's 1.6 meters tall, and that gives us a total height of 9.1 meters. Number 6 says, an angle of elevation from the top of your house to the building across the street is 65. So there's your house, there's a building across the street, angle of elevation is 65 degrees. It also says the angle of declination is 28 degrees. And it says the distance from your house to the building is 20 meters. How tall is the building? Well, the main thing is we need to break that height into two separate parts. The part where we're going to use the top triangle and the part where we're going to use the bottom triangle. So tan 65 is opposite over adjacent, so x1 over 20. And if you do the math, I'll leave you to check that x1 is 42.89 meters. And tan 28 is x2 over 20. And again, I'll let you check the math, but x2 should be 10.63. And now to get the total height, we just have to add those two heights together and end up with 53.52 meters. And finally, the chart. So I haven't used the exact numbers that you were given because I want you to still think about your numbers. But we've got angles, side lengths, and trig ratios. So let's first talk about 36. Is 36 an angle, a side length, or a ratio? Well, I think that it's a side length because it's in meters. The next thing is 12 degrees. Well, that's got to be an angle because it's a degree. The next thing is tan 23. So I know it's tan 23 degrees, so you might want to put it in angles, but tan itself is a trig ratio. It's opposite over adjacent. And 12 meters over 3 meters, since it's meters, we want to put it in side lengths, but it's 12 over 3, so that's a ratio. It could be the opposite over adjacent or something like that. So that is a trig ratio. So this is what your chart should look like with some different numbers in there. All right, so make sure you get that corrected so you can learn from your mistakes and do better next time.